Query number 1 asks us to show the number of crimes, the number of arrests, as well as the number of on-premise crimes within 3 blocks of each business. So to do this, I used the Python bokeh library, which is similar to Plotly, and in order to actually show my visualization, I call the bokeh server, and then I show my query1visual.py. So doing that will open a localhost browser window. This brings us to my default graph. So this graph shows the total number of crimes across 2002 through 2017 for my first business, which is Acapella Bistro. So hovering over each bar, you can see the total of arrests, which are represented by the green, which is for the arrest field equaling true, and then the red stands for no arrests. So adding these two totals together will give you the total number of crimes for that year within 3 blocks of this business. This range slider allows me to show the number of years in my graph. However, I was unable to resize my X range. I can select different businesses, or in our case restaurants, with the drop-down menu. And then as you can see, I did not include on-premise crimes, and this was because I was unable to grab the on-premise crimes in my query 1. So if we go back to our default settings, Acapella Bistro, and from years 2002 through 2017, I can select this toggle by type, which will reset my entire visualization and give us a graph of the total number of crimes per crime type within 2002 through 2017 for Acapella Bistro. Unfortunately, I was unable to implement changing restaurants in this mode, as well as changing the number of years represented. I was also responsible for query number 2, which at the time of this recording I was unable to implement. However, for query 2, I wanted to do something similar to this graph, which was also done using the bokeh library. For query number 2, it asks us to display the probabilities for each crime type using several machine learning techniques.
Hello everybody, this is query 3. So essentially I'm going to first go over the way in which the dataset was created. So the query 3 dataset was created from the census dataset, the crimes dataset, as well as the demographics dataset. From the demographics dataset, we were able to find the number of people who committed a certain crime within a year based on their actual age group. So essentially, if we have one crime in an area, we normalize it by the population size within the census block and find how many people have committed a crime in their respective age groups. So for instance, in this example on the row, there's one crime committed in 2001 for other offense. 0.2 of them are within the age group of 0 to 19, 0.61 are in the age group of 20 to 64, and then 0.19 are from num crimes greater than or equal to 65. So essentially, this entire data is taken and then parsed through this program here that I've written, and essentially what it does is it takes your own user input and then will dynamically generate our graph for us. So if we here run this Python program, it's going to prompt us for, there we go, what kind of year we want. So as an example, I've selected year 2018. We're going to write in our census block 816001011, and we're going to type in robbery as our crime. So now it's going to generate our graphs here dynamically, and now we've opened some web pages here from the API Plotly, and now we can see just exactly what we wanted to display. So what I've done is I've printed 3 different graphs, one to show a kind of minimalistic view of what exactly the user wanted to show. So right here we can see the exact census block, our crime, so our crime type, which is robbery, and the year we selected. So we can see from this data that there's been one crime that fits this nature, and then that 3 different age groups have that respective proportionality crime. So that is that one graph, and the second graph here that we can see is the all crimes of the same type within the same year, but with different census blocks. So essentially what this is doing is it's comparing our census block choice that the user selected by the same crime type in the same year versus aggregate it all versus just the one selected one that we chose. And we can see that obviously there's more census blocks, so that there's going to be a greater disparity here, and we can see that data reflected. And then the third graph that I've generated does the same thing essentially, but with different crime types. So this is only a slice of the pie robbery of the entire crimes that happen within this year within the same census block. So essentially, what we do from here is that we can embed these graphs that are generated onto our GitHub page and then dynamically display our data. So that was query 3.
For query number 4, I took the output CSV file and parsed the data along the x-axis with the average review rating from left to right increasing, along with the restaurant and the address. In the y-axis, we have the total number of inspections, and to break that down even further, in green we have the number of fails, in orange we have the number of conditionals, and in blue we have the number of passes within those food inspections. You can see there is a slight trend moving left to right. The higher the review rating, there tend to be a greater number of passes than there are fails. It doesn't correspond to every single category that we have here, but there definitely seems to be an increasing number of passes as a higher review rating. As you hover over each one, you can actually see the total number of each pass, conditional, and fail labeled at the corresponding color. Did all this with Plotly. I was able to parse all the data and then push different lists with the number of inspections. I had to create a list with the total number of fails, total number of conditionals and passes, and then also push the list combining the average review rating, address, and the corresponding restaurant.
In the fifth query of the data integration and analytics task, we have to perform sentiment analysis of Yelp reviews for each restaurant. That is, we divide the reviews into positive and negative sentiments for each restaurant. The Python code that I wrote for this query uses text blob to read each restaurant review, and the output is a sentiment. Also from the sentiment, I get the sentiment polarity, which is provided by text blob. So if the polarity is positive, I get a sentiment label of 1, and if the polarity is negative, I get a sentiment label of 2. This output is printed onto a CSV file as restaurant name, sentiment label, and restaurant rating. The restaurant name and the restaurant rating in columns in this file are independent variables which are taken directly from the manual reference dataset. While the sentiment label is a dependent variable which is generated by reading reviews for each restaurant. Also, the output of visualization, the visual output that I produce for this file is a stacked bar plot, wherein I have plotted the count of the sentiment against the restaurant names. So a user can determine how desirable a restaurant is by looking at the ratio of the positive portion to the negative portion of each restaurant. I have also neglected the ratings because I felt the restaurant rating column, because I felt that it would not be of any use to display this column in the visualization task. The sixth query requires us to identify how sentiments relate to the review rating by plotting average ratings against most frequent overall sentiments. The Python code I wrote for this query takes as input the output of the previous query, which looks something like this. From this file, I read two of these columns, the sentiment label and the review rating for each restaurant, and I produce a file that looks something like this. The way I get each row of this table is by getting the maximum count or the maximum overall frequent sentiment label. As you can see, the frequent sentiment label here is 1, and I average the ratings here to get the average review rating for each restaurant. That's how I do this for all restaurants, and that's how I get all the data for this query. The way I visualized the data for this query was by using a scatter plot of average ratings against the sentiment label. The sentiment of 1 is a positive sentiment, and the sentiment of 2 is a negative sentiment. As you can see, the density of points is high over here corresponding to higher ratings, higher average ratings for a positive sentiment. And since I had just one such one negative sentiment, I could get a plot over here of a negative sentiment with a low average rating. But you can also see that there are some points which are uh, offset from the actual model, and this implies that my model is not as accurate as it's supposed to be. Now, the seventh query requires us to predict review ratings using text from Yelp reviews, and also to calculate precision recall and F1 score measures. The Python code I wrote for this query is a bit complex since it uses machine learning models and classifiers in order to read the text reviews for each restaurant and predict the rating out of them. Basically, what I do here is I read the data from the manual reference data set and use stratified k-fold to split the data into 10 parts. What this iterative for loop does is that it uses 90% of the data as a training data and 10% of the data as test data. And this is done for all of the 10 samples. And it calculates the precision recall and F1 scores. The output of the Python file generates a CSV file which looks something like this, where I have the restaurant review and the predicted rating for that review. Now, for visualizing this data, I initially thought of using an XY plot where the x-axis would be the restaurant review and the y-axis would be the predicted rating, but I felt that it would make no much sense as far as visualization is concerned. So rather, instead of plotting the reviews and predicted ratings, I used the precision recall and F1 score measures and plotted them in a table format. As you can see here, each of the ratings from 1 to 5 are classes, and I calculate the precision recall and F1 score for each of these classes. I display them on a table so that the user can see the values of each class. The overall accuracy of my model is just 38%, which is too low. I tried improving on the accuracy, but I wasn't successful in doing so.
This is query 8. The way we generated the data initially for query 8 was by joining the food inspection dataset and then joining the business license dataset. Now, what we're able to do from these two datasets is determine when there is a failed inspection, the date, and determine when a license is revoked after the fact. That's the way in which the years are computed. And then we have a related name of the restaurant and the actual address of the restaurant. So we have a few restaurants here generated from our manual reference data set. I've created some Python code in order to generate our graphs here by calling an API called Plotly. What we can do is now we can take our data, we can input it into my program, and we can run the program. And essentially it's going to generate our new graph here. And now we can see a new Plotly instance being joined and created. We have an axis of Y as the age for years that it took for the inspection to completely close down the business. And then we have our x-axis being the restaurants and then ordered chronologically. So starting from 2010, at least our first data point, going to I believe this says 2018, but it's gotten cut off here. But this shows our data being generated. And now this is embedded into our website. So we can go to our query 8 over here. And then we can see that it dynamically gets loaded into the web page right here. So it's loading, and now we have an instance here. So now we can just view some of the data points here. We can say, oh, this is 4.35 years. This instance took 2.44 years, and then we can perform some analysis on that later if we wanted to. This is query 9. The way in which I was able to create the initial query 9 dataset was by joining 3 datasets together, by joining census and crimes as well as business licenses. From these 3 datasets, we were able to join them together and find 4 attributes. We were able to find the census blocks, the number of businesses with liquor licenses, the number of crimes, as well as the number of arrests. And the reason why you're seeing 100 for all the number of crimes is because the way in which we parsed the original crimes dataset was so that we could return at least 100 entries from each unique census block. So that's why all the numbers are the same, because we capped it off due to the sheer size of the actual file. The actual data points are unique and do still hold value. Now what I do is I run this dataset through a program that I created, and let's just run it right here. We can see what happens. We're given a prompt for input So right here we can input our chosen census block to visualize. So as an example, I chose 3301001010. Now this is going to generate our plot here, and now it's going to open this two web pages. Actually, we've generated two graphs from this. One is going to show our specific instances data, so it's going to show specifically for this 330 number that we chose, and it'll load on your screen in just a moment right here. So we can see the number of businesses with liquor net licenses, the number of crimes, as well as the number of arrests made under the census block. And now the same thing can be seen, except also compared against all the census blocks and all the crimes. So obviously we can see that there's many crimes being committed. So we have a big number, 4,000 crimes versus the 100 committed just in the census block, as well as a comparison of arrests, as well as a comparison of businesses with liquor licenses.
Query number 10 was fairly straightforward. Did the same thing as some of the past queries in terms of taking the output CSV file from query number 10 to a Python file, and then using Plotly to take the parsed data and send it to a graph. Fairly simple graph here. We have the probability of robbery in summer 2018. On the y-axis, we have the probability of robbery in percent. And on the bottom, we have all the months separated by each month, and then also within each month we have the census block for that given area. And then if you hover over here, you can see the month, the census block, and the percentage as we go through. Here, for instance, we have 28.57% chance of robbery for July in the corresponding census block.